So, the last time we were here, we were talking about the three rules that the rays of light follow when they refract through a lens. And I'm going to go through the rules again. And I'm also going to go do some past paper questions based on these uh, rules, basically, and how they are asked in the past papers is something that we want to understand. So we go rule number one, a ray of light which is parallel to the principal axis. We can zoom around this thing just to look at the rules being followed. If you see a ray of light is parallel to the principal axis, it refracts in a way that it passes through the focus of the lens. That's rule number one. Rule number two is if the lens passes through the optical, if the ray passes through the optical center of the lens, it has to go undeviated, undeviated. That's rule number two. And rule number three, if the ray of light looks like it is coming through the focus or it is literally passing through the focus, once it hits the lens, it has to refract in a way that it comes out parallel to the principal axis, that being the principal axis there. Okay, so this is rule number three. So, yes, all the rules are being followed in this one screenshot that we have. And if the rays of light coming from the tip of the object have converged to meet at that point, that's where the tip of the image is going to be. In this case, you've got a real image created, you've got an inverted image, you've got the height of the image smaller than the object, so it's diminished in a way, and the distance of the image is between f and 2f in this uh, screenshot. The point is object is placed beyond 2f. If you can see, this is the focus, so this is the focal length, and this is 2 times the focal length, and that is known as the center of curvature for the lens. The point is object here is placed beyond the center of curvature, and that is why it's said over here distance of the object is greater than 2f. Okay, so this is one of the positions of the object relative to the lens, and you have it here in the image, but we are going to go look at other positions also. If the object is moved beyond, moved to right at 2f, if the object is placed right at 2f, what kind of an image are you going to see? If the object is between f and 2f, what image you're going to see? What kind of an image you're going to see? So those are also a few scenarios that can be asked. Is we change the position of the object and we look at what kind of an image we're getting. So here you go right at 2f. So I see that the image is inverted and it's a real, and it is the same size of the as the object. You can place it between f and 2f. This time I see image which is magnified. It is beyond 2f. It is inverted. It is real. Right at f, there I see that the rays, after they follow the rules, are refracting in a way they are parallel to each other. They're never going to meet. So there is going to be no image created. Well, there are places where it's said that the image is going to be created at infinity, which is completely your uh, paradox to deal with. If the parallel lines meet at infinity, that is why the image is going to be at infinity. So you know what we can write, it's no image created or image at infinity. It's one and the same thing. Anyways, what if the object is placed between f and the optical center of the lens? Well, this is what you're going to get, and a virtual image. In that case, look at the rules being followed. There it is. A ray parallel to the principal axis goes through the focus. A ray through the optical center goes undeviated, and a ray which looks like it has come through the focus comes out parallel to the principal axis. So all the rules being followed, but the refracted rays after they hit the lens have diverged away from each other, and that is why there's going to be no image created. No. your mind is going to fool you into thinking that these diverged rays are actually coming from the same side as the object. So all of them extended backwards will look like they have come from this place. And that is why the image is going to be created out here in your mind. It's a perception, it's not real, it's virtual. And that is one of the most important cases in IGCSE. They keep on asking th- for you to create image in case the object is placed between the focus and the optical center of the lens. Very popular. So you're going to have to keep this one diagram in your mind. So this is something that we have already seen in the videos and in the lectures and everything. What I want to do today is actually make you practice some questions based on them. And that is why I am recording this a whole video today. So there it is, the focal length. So there is a lot of ruler to be used in these questions. I don't have a ruler online to measure these lengths, but let's see what I can do with what I have. So the focal length of the lens is 3.5. Mark and label with letter F the position of the two principal focuses. Uh, 3.5, I don't know. It may be somewhere here, there. So I'm going to have to mark this distance. I'm going to call it F. On the other side, also 3.5 centimeter, I'm going to call it F out there. That's how I get this one mark. If this length is a 3.5 centimeter, if you measure it with a ruler. Okay. And I see that the 7 is going to be somewhere here. So that's 2F for you. 2F for you on the other side. Uh, Draw three rays to locate the image. So I'm going to go follow the rules. So there it is. Rule number 1 has to pass through the focus. Rule number 2 being followed, and there it is. It has to come out parallel. So I can actually see that the image is is being formed somewhere crazy out there, which I feel is a little uh, unreasonable. Let's give me a second. Let me see what to do. So yes, it's true that the object is placed between F and 2F. We will be a little careful this time with the focus. I'm gonna go place the focus somewhere here for it to be like in the uh, diagram, the image. I want the image to be in the diagram. I don't want it to be on some other side on the page. So I'm gonna go place 3.5 out here. I'm gonna take the same length. Let's take the same length and mm, let's see, same length there. That's where I'm gonna place the other focus there. And now I'm gonna go use the rules. So there it is, rule number 1. And there it is, the rule number 2. Thankfully, this time I see they are meeting on the page itself, somewhere there. So there is where, so they wanted 3 rays to be drawn. So I'm going to go draw the third one, which seems to go like this and meets the other 2 rays out here. That's where the image is going to be. And let's see what else they have asked for. Draw 3 rays to locate the image. Draw an arrow to represent the image and label the image I. So labeling it is also very important. So I'm going to go extend this thing and place an I out there next to the image. I'm going to put arrows. Arrows are also important and they are marking points. So there, that's how you complete your sketch for 3 marks here. State 3 properties of the image. Well, the 3 properties I see is that it's real, it's inverted, and it's magnified. It's larger than the object. A student incorrectly states that this lens is being used as a magnifying glass. State how the image produced by a magnifying glass is different from the image in image I. Okay. Well, if an image is being produced by a magnifying glass, it has to be a virtual one, it has to be upright, and uh, s- virtual and upright, it will be magnified. So, state how the images formed by magnifying glass is supposed to be virtual and upright, and also same side as the object, same side as the object. The student moves the object O to a position P so that the lens acts as a magnifying glass. On figure, mark a position, possible position for P. Well, I can go place the object between the focus and the optical center. I can place it somewhere here, there. So that is one other marking point that I'm going to get in this question. So let's go check out what the answer is in the mark. So you can see about how an image created by a magnifying glass is different. They say image produced by a magnifying glass is with a brackets around it. It means it's not necessary for you to put up image produced by a magnifying glass is. That statement is not important. You need to have upright, not inverted, or virtual. So one out of these three, we have written all three of them. So we are uh, correct. And position marked between the between the principal focus and the lens. That's where P should be according to the question. And yes, we have it between the principal focus and the lens in our sketch there. So yes, we are correct. Let's show you another one. Draw two rays to locate. So now there it is. Another kind of a question. Uh, I've been telling you of all the questions that can be asked from ray diagrams in lenses. One is to locate the image. In there, object can be beyond 2f. It can be at 2f, which actually was seen in the Feb March paper recently. To 2026 Feb March paper, this was a thing. It was placed right at 2f. It can be placed between f and 2f. It can be placed between the focus and the lens. That's the most popular situation in case they give you a ray diagram to locate the image or create the image. Second is when image is given to you, an object is to be drawn. That's another kind of a question asked with ray diagrams. Third thing is specific to paper 2, sometimes in paper 4 though, I have seen that they ask the location of the image, location of the image, if the location of the object is already explained. That's a paper 2 kind of a question which is asked. So I'm going to go practice a little bit of these, and then we are going to move into the P2 kind of questions today. So there it is. This is the second kind. Image is given, an object is to be located. See, one rule for sure, uh, a ray of light must have reached the tip of the image if it has passed through the center of lens without deviating at all. Another rule is a ray of light must have come out parallel to the principal axis if it has passed through the focus. There. So these should have been the rays which created the image. Let's see. Rule number one, a ray of light, if it had come through the optical center of the lens, it must have gone undeviated. So there it is. A ray of light must have come parallel to the principal axis if it had come from the focus itself. And that is why these two are the correct rays, and these two will help you create the object in this diagram. Well, that's where the object is gonna be. There. There. Okay. So that was the question. I'm going to go label it as O because that's what they want. We can also verify our answer by looking at the third rule. If a ray of light is parallel to the principal axis, it has to go through the focus. And yes, it goes through the focus and meets right at that point. So our method is correct and the location of the object is correct. Okay. So ring all the following distances that are equal to the focal length. Well, CB is also equal to the focal length. This length is also equal to the focal length. They wanted us to create a ring around it. So there it is. AC, ring all the following distances that are equal to the focal length. AC is also correct. And AB is not equal to the focal length. 2AB is not equal. So there it is, your 5 marks. I can put up arrows actually to put up, uh, to create an image in this sketch. There it is. Let's go do some other questions. This is also a very important kind of a question. They give you a grid and they mark the position. So you're going to have to literally measure. They're saying that one square here is 1 centimeter. So if the, let's see if they've mentioned anything. Yeah, they say that the principal focus is 5 centimeters. So there it is. 1, 2, 3, 4, 5. That's where the principal focus is. 1, 2, 3, 4, 5. That's where the other principal focus is. I'm going to go label them F and 1, 2, 3, 4, 5. There, F. Okay. So that is our first thing to do. Uh, let's see what else. Mark both principal focuses and label each of them F. By drawing on figure, find the position of the object and add object to the diagram. Where is the object going to be? Okay. Describe what is meant by the principal focus for a thin converging lens. Well, it's a standard answer that you want to put up with these. I'll show you what the answer is supposed to be. Well, it's the place where the rays of light which are parallel to the principal axis meet after they refract through the lens. So let's show you a marking scheme, correct answer to it. A point where the incident parallel rays meet after passing through the lens, origin of the rays that emerge parallel after passing through the lens. One of these three is good enough. I would prefer it to be point where incident parallel rays meet after passing through the lens. Well, that's what I would want it to be when they want you to explain what the focus is for an optical lens. Okay. So measuring mm, and also mentioning that the focus is supposed to be on the principal axis is the other marking point. So it's a point on the principal axis. I'll write it down for it to be like written in your notes. It's a point on the principal axis. So this is a very important thing, please. This is a marking point, so we should include it in our definition. If it's not what you've written in your notes, a point on the principal axis where incident parallel rays meet after passing through lens. That's a proper 2-mark answer to it. Okay, so you have it. You keep it in your notes. Very important, this thing. Okay, let's see. So we're going to go look at what else they have asked in the question. Underline the terms that describe the nature of image produced by a magnifying glass. Well, it's enlarged, it's this upright, and it's virtual. These are the three things that I see for an image in an image created by a magnifying glass. Okay, let's see what else. Let's complete this question by drawing on the figure, find the position of the object and add object O to the diagram. So, okay, so I'm going to go follow the rules. So, a ray of light must have come through the center and deviated. A ray of light which has come out parallel to the principal axis must have come through the focus. Okay. Now, there is a concern here. They literally say that the lens here is used as a magnifying glass. Now, there is something about images being created by magnifying glasses that you should know. The point that the object is supposed to be between the focus and the lens for the lens to be used as a magnifying glass. So if I go follow the rules, rule number one, there it is. That's one of the rules being followed. I'm pretty sure I need to place the object between the focus and the object. So the object needs to be somewhere here. That's where the object is supposed to be. So I'm going to go and make sure that my object is between the focus and the lens and it is on the same side as the image. So that is what I'm going to go do. Let's see. Well, I know if a ray of light looks like it is coming through the focus, but it comes out parallel to the principal axis, that's one rule that I know. So that must have been the ray which refracted to come out parallel to the lens. And that is why once I join these two, that's where the object is supposed to be. And I'm going to go draw virtual extensions for the rays to look like they're creating a virtual image. And here also, I'm going to make sure that the rays are virtual when they create the image. Well, that's where the object is supposed to be there. So, a very tricky kind of a question, this one. They've mentioned that the lens is being used as a magnifying glass. And they want you to locate the object. Well, it's a requirement, it's a prerequisite for the object to be placed between the focus and the lens. So the object is supposed to be somewhere here. Now, how do I locate the object? Well, I'll follow the rules. Well, a ray of light which passes through the center should go undeviated. A ray of light which looks like it comes through the focus should come out parallel. Well, both of them are actually diverging away from each other. Where are they meeting? Well, they look like they're coming from here on the same side as the object. So that is how you're going to do this question. A very nice one, this one, 321, 321 from the P4 book. I would highly recommend sketching this out by yourself in your notebook. I'm taking the measurements as 1 centimeter for the for one box or for your grid that you create. Use a figure to determine the distance of the object from the center of the lens. Well, it looks like that the object is 1 to 3 centimeters from the lens. So we write down 3 centimeters. Okay, so that was a 321 question. Very, very nice question. Okay, let's see. Complete the path of the rays of the two rays from the object to the screen. Figure shows a converging lens producing a sharp image of object on the screen. Well, if a sharp image is being created on the screen, the rays coming from the object must meet right at the screen for a sharp image to be created. A blurred image is going to be created on the screen if the rays do not meet right at the screen. And that is why we need to make sure that the rays, after they refract, meet right at the screen. As far as the rules that we have been talking about are concerned, well, I don't see any of the rules being used here to create the image. And the only idea that we have used is a sharp image can only be created on the screen if the rays from the object have met at the screen. Okay, let's see. So that was your sketch. Now let's go. Part B is replaced with a thinner converging lens which has a longer focal length. If the focal length of a lens is longer, well, these rays of light will meet further away on the principal axis. If you have kept the screen where it was initially and not changed the position of it, this time the image is going to be blurred and it is going to be created at a point beyond the screen. If you have a longer focal length, you are expecting the image to be created beyond the screen. So it will be created somewhere there. That's where the image is going to be. That's where they're going to meet. So that again should be seen in your sketch. Complete the path of the two rays. So that is how. So let's go look at the marking scheme for it. Part A, they say both the rays straight to the left of lens and top ray bends clockwise and bottom ray bends anti-clockwise. Both rays converge to meet on the center line at the screen. That was part A, the one that we have drawn first. There, center line on the screen. Okay. Now both rays straight to left of lens, top rays bends clockwise, less bending as it was in A, and bottom ray bends anti-clockwise. Both rays converge to meet beyond the screen. Okay, so beyond the screen. That is how. So less bending observed, and on the left, they're supposed to be straight. So yes, we have drawn them straight on the left of the lens. So that was about it. A converging lens is used as a magnifying glass. The focal length of the lens is 10 centimeter. Describe the position of the object in relation to the lens. Well, for a lens to be used as a magnifying glass, the position of the object should be between the focus and the lens at a distance less than the focal length of the lens. That is how it should be. Describe the position of the image in relation to the lens and the object. Well, it is on the same side as the object, and it should be further away from the lens compared to the object. Okay, three properties of the image formed by a magnifying glass. Well, they are supposed to be virtual, they're supposed to be enlarged, and they're supposed to be upright. These are the three properties that you want to put up. Okay, so these were a few questions I wanted to talk to you about. Okay, so we did 3:26 just now. I would like you to go and look at a few other questions like 3:30 here. 3:30. This is what you would want to do. You would want to do 3:32 also. 3:33 also. So you would want to practice such questions. I'll list them up: 330, 332, 333 from the P4 book. The link of this book is in the description of the video. Okay. So this is what you want to do: 320, 330, 332, and 333. Right? Yes. 332 and 333. Let me have a look here. Yeah. And 335 also. 4 questions for you to practice. This is all from P4. Now we're going to go do some P2 questions. Okay. Let's see. What kind of a P2 question can be created with these rules is what we're going to see. The 3 rules that we have been talking about. Light, 477 on the P2 book. Okay. The diagram shows the path of the 2 rays. An object is placed. An image of the object is formed on a screen to the right of the lens. How does this image compare with the object? Okay, so we are going to roughly extend these 2 rays to see where they meet. Well, I see they meet somewhere there. So that's where the image is going to be. How does this image compare with the object? It is larger and inverted. It is larger in the same way up. It is smaller and inverted. It is smaller in the same way up. Well, it is larger and inverted. Well, that's what it is. So answer A. So yes, direct application of the rules we were talking about. So that was 1141 from the P2 book. Let's go do some other questions. Okay, let's see what's happening here. What type of an image is created when the object is in this position? Oh yeah, this is a situation where the refracted rays have diverged away from each other. I've been telling you, if the rays have diverged away um, from each other after the refraction, well, you're gonna see a virtual image. So the image is gonna be somewhere there. That's where the image is gonna be. It's gonna be virtual. It's gonna be enlarged there. Okay. So that was another kind of a question. Let's see. Let's look at any other kind of a question which may be asked. And I wanted to show you. I wanted to show you different kind of questions, like I told you. In this case, you see which statement is correct is what they're asking. The image is diminished, the image is inverted, the image is real, and the object is closer to the lens than its principal focus. You can literally pause and try it by yourself. I'm pretty sure you'll get what the answer is. Uh, these two are literally points here. You can't claim the thing to be diminished or inverted. It being real is a question. You see how the rays are diverging away from each other. Well, they're not going to meet on this side. So there are virtual extensions being drawn. Images created by these virtual extensions, it's not real at all. And of course, there's something that you can actually see the object is closer than the to the principal focus. The object O is closer to the lens than its principal focus. Only then will you have a virtual image being created. The object must be closer to the lens, then it's principal focus. So there. Uh, then it must be between the focus and the lens. So that's why the option D is the correct one out here. Okay. Let's go do some more. That was 1171. Remember, the answer at the back in the book is wrong for this one. The answer is supposed to be D. Okay. So let's go. Okay, this is where it gets interesting. These are the kind of questions you would want. Which position of the object produces a virtual image? Well, the object needs to be between f and 2f. There it is. Between f and lens. That's where it is supposed to be. A is the answer. Okay, so questions like these. This is what I want you to do. The object is placed 8 centimeter from the thin converging lens of focal length 5. Which statement about the image formed by the lens is correct? The image is, when the object is between f and 2f, well, that's what the situation is. 2f is at 10. The object is between f and 2f. What kind of an image? Well, you see an inverted image, you see a real image, you see an image which is larger than the object. It'll be created somewhere here, that's where it's gonna be. So we go and choose those. The image is real and inverted, the image is real and upright, no. The real and virtual, no. Virtual and upright, no. This is the only correct option. So those were a few questions that you wanted to check out, and we're gonna go give you a few of them. 1195, you can go do this one. 1195, you from the P2 book. You can go 1196, 97. These are all from lenses. 98, 1201. Oh no, 1202. Sorry. 1207. 1209. You know, so that's all from P2. And these are the ones we want to do from P4. Okay, so take a screenshot. This is what you should do before we meet um, in the next lecture. Let's see. Okay, I'll see you. Bye.